Hi guys, welcome to lesson 7.3, similar polygons. So last lesson we talked about ratios and proportions. Now we're going to apply them to shapes. Alright, now before we get really started, let's first get a definition for similar polygons. So polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. Now this is important. The shapes, the angles, the sides have to be corresponding. Okay, this will be a big deal later, especially as pictures start changing, where they're sitting. So look down here at the diagram. We have diagram A, B, C, D, and it is similar to W, X, Y, Z. So if you look at these two polygons, A is in the top left, W is also in the top left. They are both marked with the congruency mark, fitting the definition. And the other angles are also marked. When you write a congruency statement, order matters. All right, stars, arrows, order matters with congruency statements. That's kind of what I was saying up here about the corresponding bit. If you were to change up the letters of your shapes, then they are no longer the same shape. Okay? So what that means is I can't say that A, B, C, D is similar to Z, Y, X, W. Okay? Because remember, corresponding angles have to be congruent. And angle A is not congruent with angle Z. So when you go into your homework where you do any problem, first make sure you have the proper orientation. You have to make sure your angles are lined up to the corresponding ones that are congruent. If you have to redraw the picture, that's always a good idea. So let's practice a little bit. Here we have triangle FGH, and it is similar. By the way, this symbol means similar. I don't know if you caught that on the last slide. So triangle FGH is similar to triangle JKL. We want to list all the pairs of congruent angles and then write an extended proportion that relates to the corresponding sides. Remember, extended proportion is a proportion with 3 or more ratios. But first, we're going to list all the congruent pairs. Now this should be familiar. We've done this one before. If you need to draw it, go ahead and draw it. We have F, G, H. I'm going to draw this one smaller just for aesthetics. J, K, L. Now corresponding angles need to be congruent. Therefore, I know that F has to be congruent to J. And then the same throughout the rest of the triangle. So when I make my statements, I'm going to say that I don't need the measures. I'm going to say that angle F is congruent to angle J, angle G is congruent to angle K, and angle H is congruent to angle L. Next, we need to write an extended proportion for the sides. Now with proportions, order also matters, but in a different way. So I'm going to write out my extended proportion first, and then I'll explain what my order is. So first, I'm going to do FG, okay? Now to help with your orientation, my trick is to always draw the shapes out, and then to start at one angle, and then just trace that same line on both shapes. So F to G, FG, JK is congruent to GH over KL. It's over here. And then come home, HF over LJ. And here is the extended proportion that relates to all the corresponding sides. Now the order bit that I mentioned earlier is this corresponding sides bit. Notice how my big triangle, or my leftmost triangle, was on top, and my little triangle was on the bottom. Okay, if you did the little triangle on top and the big on the bottom, it doesn't matter. However, what does have to happen is the ratios have to match each other. Okay, we mentioned that in the previous class when we were talking about ratios and proportions just in general. In order for these to be compared to each other, they have to be in the same order. So consistently across the top, big over little. Or you can flip it and go little over big. Now in this chapter, scale factor is huge. Okay, stars, highlighters, arrows, scale factor is big. Make sure you understand this vocab word. Now the scale factor is the ratio of lengths between the corresponding sides of two similar polygons. If you remember from the other day, you'll remember me saying that a ratio compares two different numbers. Okay, well the scale factor compares two different sides of two different shapes. Okay, it's the thing that unites those two shapes together. We'll be using the scale factor a lot later to make sure that the rest of the sides are also proportionate. Now the order on your scale factor, so if you do big triangle over little triangle or vice versa, depends on the question. Some questions will say go right to left, some questions will say this one over that one. Just pay attention to the wording of your question for the order in which you create your scale factor. So if we go down here to the bottom, let's say my question asked me to get a scale factor from triangle ABC to triangle XYZ. What I'm going to do is I'm going to go down to my picture and I'm going to look for two corresponding sides. I see I have a number on AB, which means my corresponding side would be XY. Okay, right here. Now in this picture, it's conveniently labeled. However, in your homework problems, it's not always going to be. So make sure you're still paying attention to your congruency statement, or in this case, your similarity statements, to help you find congruent sides or corresponding sides. Okay. Now, the question is asking ABC to XYZ. So when I do my scale factor, I'm going to have 6 over 3, which will then simplify to 2, as is said right here. Okay, remember the scale factor is a ratio. So whenever something asks for the scale factor, you're just creating a ratio between the two shapes. In this case, it would be 2 or 2 over 1 if you want to keep that fraction in your mind. Now, if it wanted me to do the other way, as in that second example, triangle XYZ to triangle ABC, I have to follow what the question is asking. In that case, it would be 3 over 6 or 1/2. Okay? Always simplify your fractions. Now here we go. Let's practice. So we are told right away in our problem that these triangles are similar. Now, if they're similar, that means that all the sides are going to be proportionate to each other. So the first thing I want to do is find my scale factor. Okay? Because if I have my scale factor, I can then compare the other sides to the scale factor. If they're proportionate, all of my cross multiplications should work out. So here we go. I want to orient myself so I see that N and Q is proportionate to, or is corresponding to RS over here. So I have 12 over 50, or 12.5 over 10 as one of my ratios. Then see the two corresponding angles to the blank one. That is 11.5 over two corresponding lines to the blank one, 9.2. And then my third ratio is the blank one to the one corresponding line, so 15 blank to 1 over 12. Okay, so these are my three ratios for my three sides. I want to pick one of these to simplify and make my scale factor. I'm going to pick this one because the numbers are nice. The reason why I'm picking this one with nice numbers is because I can simplify this and get smaller numbers. And whenever you can, give yourself smaller numbers to work with. So I can simplify this by dividing by 3, which gives me 5 over 4. This is my scale factor. 5 over 4 is my scale factor. I'm going to compare these other two ratios to 5 over 4. Okay? Now, if these two triangles are indeed similar, then when I cross multiply, they should both come out to the same thing on either side of the equal sign. If they're not similar, then it won't work out. And here we go. Now you can clearly see that for our first one, I got 46 on both sides of the equal sign. That checks out. And then on my second one, I got 50 on both sides of the equal sign. So that checks out. The number on each side of the equal sign were the same every single time. Now a small note in case you're confused. What I mean by the same, I don't mean that this number has to be the same as this number. Okay? What I mean is that this number has to equal that, and this number has to equal that. Okay? All these sides have to be proportionate to the scale factor. And if you go back and look at that very first section, the way you prove that two things are proportionate is to cross multiply and see if either side of the equal sign has the same number, which in this case it does. Now let's get a little more advanced. So here we have two pictures. We're told that they are similar, and so now we need to find the missing sides. So using my similarity statement, I'm going to find my sides. I see that A to F would be the same thing as A prime to F prime. So that means I have 12 over 3y minus 1. Okay. Now at the moment, don't get freaked out that we have variables in here. That'll make sense in a moment, or we'll deal with that in a moment. Next, I have CD, which is 9 over C prime and D prime, which is 6. And then my third one, I have X over 10. Okay. So these are my three ratios. This one is clearly going to be my nice, easy to simplify scale factor. So 9 over 6 simplifies nicely to 3 over 2. Now, when I need to find x, y, and z, I'm going to use my other two ratios and compare them to my scale factor. Okay, so I have 3 over 2 is equal to 12 over 3y minus 1. Now I'm going to cross multiply. That would give me 24 is equal to 3 times 3y minus 1. Now all I have to do is solve for y. And there's y. Now as I'm looking at this, I realize there's a bit of a typo. If you were asking yourself where z is, that is an excellent question. Z is right here, and this bottom one is 4. So our fourth ratio would have been z over 4. Okay. Now I'm going to set up my scale factor to find x and to find z. I'll set them both at the same time. So 3 over 2 is equal to x over 10. And then I also have 3 over 2 is equal to z over 4. Okay, cross multiply. That gives me 2x is equal to 3 times 10 is 30. X is equal to 15. And when I solve for z, I have 12 is equal to 2z, which means that 6 is equal to z. And there we have it. Now, moving on to the next one, the perimeters of the two quadrilaterals. One way, a very easy way, is to plug everything in. I know that this is 6, this is now 15, y is 3, therefore this, we have 9 minus 1, this side is 8. Then you just add them all up. So the perimeter of my top one, ACDF, is going to be 42. That's the perimeter of ACDF is equal to 42. and then the perimeter of A prime, C prime, D prime, and F prime is 28. When I look down at the next problem, it says find the ratio of the perimeters. So again, I'm going to do the same pattern as I did for my scale factor. So big on little, which means that my ratio is 42 over 28. Now I need to simplify my fractions. Okay, I can divide both of those by 7 and get 6 over 4. I can divide both of those by 2 and end up getting 3 over 2, which is the exact same as my scale factor. And herein lies the second way you can find the perimeter of both shapes. Sometimes you will only be given the perimeter of one shape. But remember, if these shapes are similar, then all things a part of the shape have to also be similar, which means the scale factor, the sides, the perimeters, the areas, all of those things have to be similar, which means when you compare them to the scale factor, you can use it to find the other ones. And then when you cross multiply, they should come out to the same thing on each side of the equal sign. Let's practice this. So here we have the perimeter. We need the perimeter of two similar polygons. Okay, and here we're told that they must be proportional to the scale factor. So first we need to find our scale factor. MNPQ is similar to XYZW. So here I have on this shape, I'm looking at XW or WX. So XW, that will be corresponding to MQ. So I come over here and MQ is down here. So 4 over 8 will be my scale factor, since that's the only ratio that I can compare this to. When I simplify, I am left with 1 over 2. Now the question is asking me to find the perimeter of both. However, I don't have all the information to find the perimeter of my small shape. So I'm going to find the perimeter of the big one, and then use the scale factor to find the other one. When I add up all my sides, I get that my perimeter over here is 34. I'm going to call this one X, since I don't know what it is. Next, I'm going to set that up as a ratio. My scale factor went from small shape to big shape, so I'm going to have X over 34, and I'm going to set it equal to my scale factor of 1/2. Okay, then I'm going to cross multiply, because that's what you do to prove things are proportionate. So 34 is equal to 2x. That means that x is equal to 17. The perimeter of x, y, z, w is 17. And this method will also work for area, just like it works for perimeter and other sides. Alright guys, that's the end of this video. If you have any questions, please make sure to star them and ask in class. I'll see you next time.